All right, picking up from the last video, we finished up our example in manual operations. Okay, we did some calculations with the probability density function here, and we calculated the expected value of 130 minutes and the variance of 33.33. Now, occasionally you might want to use the standard deviation to measure your variation. So for that, you would simply take the square root of the variance. So we could easily do that in Excel, square root 33.33, and that would give us 5.77. So that'd be our standard deviation for this question. But what I want to do next is actually build this graph in Excel. And to do this, we are going to first put the possible values that X can take. Because we're dealing with flight time, we know our X values could be anywhere from 120 to 140. So that's going to go in our first column. 120, 121, 122, all the way down to 140. Okay. The next column, we're going to put our formula for probability. And that's 1 divided by the higher value minus the lower value. So we're going to put equals 1 divided by, now we know that it's 140 minus 120, so we can just put 20 in here. And there we go. There's a 5% probability of getting a 120-minute flight time. And if we drag this down, we'll see that that's the same for all of the values, 5%. Now we create our graph. And we're going to scroll over this, and we're going to go up here to Insert, select the chart, right? Standard operating procedure from prior videos. Make this a little bit bigger here. And you will quickly see that we have a uniform probability distribution. Now, because this is a continuous distribution, we need to get rid of the gaps, right? It's not discrete, so we're going to need to format the data series, and we need to pull the gaps to 0. Now we have what's known as a histogram. Okay. The other thing you'll note is that we don't actually have the flight times here. So as before, we're going to need to go up and modify our data. So let's go here. Let's go to, click on this, go here to data. Actually, I think I need to double click on this. Yeah. Select data. Right? And then we're going to edit the horizontal axis and select the data that we want it to populate there. And if you do that correctly, you will see that now you have 120 all the way to 140 and a constant 5% probability. The next continuous probability distribution we're going to look at is the exponential. And it has a probability density function of this for any x value greater than or equal to 0. And we can find the probability of any x value occurring with this formula here. One thing that's convenient about the exponential is the mean will be equal to the standard deviation. Now, this particular distribution is often used when looking at the probability of time. And the reason is because take loading time, for example, for the freight industry. The probability of a short loading time is going to be higher than a longer loading time because most freight companies incentivize their workers to have lower loading times than higher loading times. So we see this kind of distribution here. Suppose X represents the loading time for a truck at the ship's loading dock and follows exponential distribution. If the average loading time is 15 minutes, what is the probability that loading a truck will take 6 minutes or less, 18 minutes or more, between 6 and 18 minutes? Use the formula and Excel to calculate. Okay, so we're going to be using this formula here because we want to know essentially the probability of getting an X value that is less than or equal to 6 minutes. Okay. I'm going to put equals 1 minus e to the negative, and this is our x of 6, divided by the mean, which it gives us is 15. Okay. Using Excel to calculate, we can put equals 1 minus exponential, and we want it to the negative, so we're actually going to put negative 6 divided by 15, put that in brackets. Do that correctly, you get 0.3296. So let's just go ahead and write that down over here, 0.3296. In other words, there's a 32%, almost 33% probability of getting a loading time that is less than or equal to 6. That's this area here. All right, the next question says, let's calculate for 18 minutes or more. We can use the same formula, but we'll need to subtract our result from 1 in order to get this answer, because we're trying to find this area here. But the formula actually tells us moving from the left to the right. We're going to put the probability of getting an x value that is less than or equal to 18, that will effectively give us this area here, would be equal to 1 minus e to the negative 18 over 15. And if you do that in Excel, you will get, I can actually just change my formula here a bit. And instead of 6, I can put negative 18 over 15. And I get 0.6988. Okay. So that's the probability of getting an x value less than or equal to 18. That's this area here. If I want this area, I just subtract this number from 1. So I'll put equals 1 minus this, and I get 0.3011. So 1 minus 0.6988 equals 3.3011. So that becomes our answer. That's this area here, right? 0.3011. And this area here we got was 0.3296, 0.3296. Of course, the difference in between we could compile by adding these two together and subtracting them from 1. Let's do that. So we put equals 0.3011, right? That's this area here. We're going to add to that 0.3296. Okay, that's this area here. Okay. And if you do that, you get 0.6307. So that's the sum of these two. Now let's subtract that from 1. Equals 1 minus this. 0.3693. That tells us this is 0.3693. Remember, this whole thing must sum to 1. So that's how we can derive these little areas. In other words, there is a 36%, almost 37% probability of getting a loading time between 6 and 18 minutes. The next thing we're going to do is build a graph. Okay, and just like we did with the other example, we're going to put in our first column the possible values that x can take on. And we know it can take on 0, it can take on 1, all the way up to, infinity technically, but let's just go to 30 because this is where our data goes. Okay, so let's drag this down and go 0 to 30. So the loading time can be between 0 and 30 minutes. Okay. Now we're going to put in the next column our probability density formula, and that's this one right here. So we put equals, parentheses, 1 divided by our mean, which we know to be 15, and then we're going to multiply that by e. So remember the function is exponent, and that's going to go to the negative x, so negative, and our x values are here, divided by the mean, which we know to be 15, parentheses. So that's your formula. Now I'm going to go ahead and drag this down. I'm going to drag it down all the way to my 30 points. And then I have my probabilities. So let me go ahead and make this a little bigger so you can see it. If you want to change these to percentages, you certainly can. Right? That might make it easier to read. Maybe round it to the 10th place. Okay? And it follows the pattern we expected, right? Lower times are associated with higher probabilities. Higher times are associated with lower probabilities. So we would expect this downward trajectory to continue. In fact, let's verify that. Let's actually scroll over our data and build that graph. Go here to Insert. I'll put a chart, column chart. Make this a little bigger so you can see it. Okay, let's get rid of the data we don't need. Okay, notice it's taking shape. Clean it up a little bit here. Note that we don't have the correct denominations on the horizontal, so we're going to go up here to Select Data, edit the horizontal, and we are going to scroll over this data here. Okay, and click OK. Now, if you do this correctly, you will get the correct denominations. Okay? Of course, we still have gaps, and we don't want gaps because it's a continuous distribution. So we can double click on those bars and tell it no gaps. And if you do it correctly, you have your exponential distribution. Let's go back now and recognize the mean and standard deviation. Well, this is easy because the question here tells you the mean. So it's 15 minutes. And the mean is the standard deviation. So it's 15 minutes. 15 and 15. Okay, and we are done with the exponential probability distribution. Okay, the last thing we're going to do is build the normal probability density function. So we're revisiting the normal distribution now that we've practiced these uniform and exponential examples. But the normal is the common one, and this is the formula that would be used. Let's say, for example, that we know IQ is normally distributed with a mean of 100 and a standard deviation of 15. Using the probability density function here, create an Excel probability histogram to illustrate IQ from 75 to 125. Okay, so I'm going to go ahead and pull this over here. I've actually already done some of the computations. So you can see in the first column, I've got 75 all the way to 125. And then in the second column, I've created the formula. Okay. I will let you do this on your own. You can see it here. It's a little messy, but it's worth doing once so you can get down putting the brackets in the right place and so forth. But once you get it, then you follow the same procedures we did with the uniform and with the exponential. You simply drag the formula down, and from there you can construct your illustration. Now, if we do this correctly, we should get the normal bell-shaped kind of distribution. So we're going to scroll over our data. We're going to go to Insert, Column. Okay, put this in here. We're going to get rid of those bars that don't matter. Okay. That looks like we're on the right track. Okay. And make this a little bit bigger. Okay. Clean it up a bit. Okay. Now, of course, follow the same steps. We don't have the correct denominations down here, so we're going to select data. I'm going to select the horizontal axis. We're going to scroll over 75 to 125. Okay. Click OK. And now we've got our range. So you can see the probabilities are increasing up to the mean, which is 100, and then they're decreasing, just as we would expect. Okay. Now, this is a histogram, so we need to double click on the bars and get rid of the gaps. Okay. All right, that's it. So what we've done is we've learned how the different discrete and continuous probability distributions work, what information they give us, and how to construct illustrations in Excel. Okay. We can move on now to using these distributions, in particular the normal, to do statistical analysis. All right, thanks guys.